because think about this. Let's say you create a 4 terabyte fully provisioned volume. Let's say it's fully provisioned, and it's RAID 1 from your, from your SSD capacity. How much raw capacity is the RAID 1 volume going to take up from your disks? Yeah, double, right? So you're essentially, your cost, if you think about it, your cost for RAID 1 is the most expensive because it's basically, eventually at the end of the day, it's double the space, right? So the downside of RAID 1 is cost, but it's actually good. Let me talk about this first from an availability point of view. It's best from an availability point of view because let's say I have a RAID 1 volume eventually allocated from your 240 SSDs. I could actually, if I lost 50% of the disks, so 50% of my 240, or maybe even half of my cages, it's possible that if I lost 50% of my disks, I could still survive that multiple disk failure. All right. So RAID 1 is best from an availability point of view. Okay. It's also best from an availability point of view. Let's not consider RAID 0. It's best from a performance point of view. If I compare it to RAID 5 and 6. Now I haven't talked about 5 and 6 yet. I will. But one of the things with RAID 5 and 6 is there's a back-end penalty on a write because we got to recalc parities. You don't have that back-end parity calc issue with RAID, like with RAID 1 that you would have with RAID 5 and 6. And so RAID 1 is best from an availability point of view. It's best from a performance point of view on a write, like if I have a volume exported to a host and we're writing. It's also best from a read point of view as well, versus 5 and 6 because you have 2 places to read the data from. But it's the most expensive RAID level. All right. But RAID 1 is a choice. So if you think about it, if I want to create some RAID 1 volumes that, because it's expensive, I may not want 100% of my volumes to be RAID 1. But some I want availability, good performance, expensive. Use this CPG to create the volumes. All right. Now, in terms of RAID 1 though, as well, sorry, I flipped around with RAID 1. If you look over here to the right, and this kind of, Manoj, you asked a question earlier about parity calcs, and I'm going to get to that. But one thing I want to point out here is, you see up here, it's basically leading to you have to have a chunklet on a disk for RAID 1. We're going to have a mirror chunklet. And I want to kind of talk about this, and this kind of leads me for RAID 1. I'm going to come back to this, Manoj, I hope I'm pronouncing that, Manoj, for RAID 1 and RAID 5 and RAID 6. Now, about a little demonstration I'm going to give you here. You see these blue squares here, these 4 blue squares? These represent chunklets on your SSDs. Remember, you got 240 SSDs. These are just 4 chunklets on 4 different SSDs. So remember, your chunklet size is fixed to the gig. Okay? Now, these represent some chunklets on 4 different SSD disks. Now, remember, your chunklet size is fixed to the gig. Now, one thing I want you to realize is chunklets don't belong to a volume. Chunklets belong to a CPG, right? Let me give you a little bit of a segue because I had a student a couple of years ago. She said to me, this is what she said. She said, well, actually, remember, the smallest volume you can create is a gig. You can create a 1 gig volume. And she said to me, she said, well, what if I create a 1 gig volume? She said, I assume there'll be 1 gig chunklet on a disk and all my data will be in that chunklet. Then maybe another chunk, another chunklet for mirrors or parity or whatever. But that's not how it works. Chunklets don't belong to a volume. They're not owned per se by a volume. Chunklets are owned by, you might want to think of it this way, chunklets are owned by a CPG. So let's say these chunklets here were owned by a CPG, CPG-X. This is the name of my CPG, whatever, let's assume it's RAID 1. What happens is you create the volumes using the CPG. Chunklets are allocated from the disk and kind of used by the CPG. All right. Now remember this CPG here, let's assume this is RAID 1. Okay. Second here. So this is a RAID 1 CPG. All right. So it's called CPG-X, it's RAID 1. All right, now, yeah. So LD is a group of chunklets and group LDs. So yeah, let's assume this is chunklet, this red box is kind of an LD, think of it that way. So LDs belong, if you will, to a CPG. These are chunklets owned by the CPG, they're grouped together in an LD. So chunklets that are grouped together in a logical disk are kind of the formation of the volumes using that CPG, all right? So what happens, then each chunklet is broken down into a unit of measure called a region, which is 128 meg. So if you did the math here, this is a chunklet, follow red bouncing ball, 128 times 2 is 256. So each 1 gig chunklet is broken down into 8 128 meg regions. 8 128 meg regions for this chunklet. Now, what eventually happens in these regions of 128 meg, and let me just kind of use one of these regions here. The regions on the disk, now remember these are chunklets on disks down here, right? These little red squares represent a 16K page on disk. Okay, so what happens when a host writes? So let's say I create a RAID 1 volume here using this CPG. Brand new volume, I export it to a host. What happens for a write is the host writes to the cache of the controller. Now remember I used this term earlier. Your cache is kind of chopped up into what we call 16K. This represents my DRAM cache over here. And your cache is chopped up into 16K cache management pages. So for a write, let's say I create a volume here using this CPG, I export it to a host. The host writes. We've got all the 16K pages from disk into cache. Then eventually we've got to flush this CMP down to disk. So for RAID 1, what happens is as a 16K page is written into a region on a region in a chunklet. This is 16K page here, this purple square. It's going to be mirrored onto another chunklet on another disk. All right. Eventually we flush a 16K page from cache down to disk here. It's going to be mirrored into another region on another chunklet on another disk and also on another cage if you have 2 or more cages. So this and the mirror of it, let's assume they're different disks but also on different cages. As long as you have different, because it's always trying to lay the data out in the most highly available way. All right. So I'm going to flip back here when I talk about RAID 5 and 6 as well here a little bit. But what this slide is a little bit misleading about here is you might think of this, that this is a chunklet and the chunklet is mirrored. It's essentially a 16K page within a region of the chunklet that's mirrored. But at the end of the day, all your data is mirrored, right? But it's at the 16K page level. So that's RAID 1. Let's talk about RAID 5. Now, again, we want to talk about these things from a cost, performance, and availability point of view. Now, when I talk about RAID 5 here, I'm going to bring a number of things into the conversation here. And before I even talk about this, I'm going to push out another share here, and I'm going to back in CPGs here. I'm going to create a new CPG. Now, when you create a CPG here, you give your I'm going to click on the advanced options up here in the top left corner. You give your CPG a name. Choose the array you want to create it on. And of course, you choose the device type. I'll leave it FC here. Of course, then the RAID levels here we just talked about. So I'm going to create, this time I'm going to choose RAID 5 for my RAID level. Okay. It's telling me I should use RAID 6, but I'm going to keep it RAID 5. Now, under the RAID type, you see this option here, set size. Okay. For RAID 5, even 6, even 1, you can change or have different CPGs with different set sizes. A set size of 2 plus 1 is what we call a 3, a set size of 3. You could have a CPG with a set size of 5, a 4D1P, up to a set size of 9, which is an 8D1P. All right. So for RAID 5, you can create CPGs that are RAID 5 and then CPGs with different set sizes. Now I'm going to just click on cancel, or I'm going to click on stop. All right. So let's talk about RAID 5 just in general. And let's say I create 3 CPGs. This is called CPG X. And this is a RAID 5 CPG using all my SSDs. And this CPG has what we call a set size of 4, which is a 3 plus 1, 3D plus 1P. All right. Now, let's say I create 3 different RAID 5 CPGs. Let me just kind of copy and paste here. Watch what I'm going to do here. All of these are RAID 5 CPGs. All 3 of these. They're all RAID 5, but they have different set sizes. Okay, so let's talk about this, and let's talk about RAID 5 and set size in general. RAID 5, let's talk about availability first. If I compare RAID 5 to RAID 1, RAID 1 is not as highly available as RAID 5, as RAID 1. Because at the end of the day, when a host writes into a chunklet, into a region on a chunklet, the parity is going to be on for the stripe, and I'll get into this. The data and the parity are all going to be on 2 different disks. But if I lost 2 disks at the same time, or more than 1 disk, there's a possibility I could lose the data and the parity disk, and the data would be compromised, RAID 5. Remember, with RAID 1, I could lose half the disks and be okay. The issue with RAID 5 is if you lost 2 disks or more, there's a possibility, it's not guaranteed, that the data and the parity to reconstruct the data on 2 of the disks that you've lost, and then the RAID 5 data could be compromised. So RAID 5 is not as highly available as RAID 1. All right? But here's the good news with RAID 5. Cost. It's cheaper than RAID 1. Talk about cost. All right. Now, RAID 5 is cheaper than RAID 1. But depending on the set size, varies. I mean, let me see how I can say this. Depending on the set size you use for your RAID 5 CPG will impact that cost decision. If I have the set size determines the data to parity ratio. All right. So what happens for follow the red bouncing ball for RAID 5 set size of 4 CPG, and then you create a volume, use allocating those chunklets using the CPG. It's going to write a 16K page, do a region on a chunklet, 16K page, 16K page. So for every 3 writes into a region, the 16K, it's going to then hop to another chunklet on another disk and write parity. It's going to do 3 plus 1. So every 3 page writes 16K, it's going to write a 16K parity page. So I want you to think about this. Let's say I create a 3 terabyte volume that's RAID 5, set size of 4. Well, how much raw capacity is it really going to consume at the end of the day on the disks? 4 terabytes. So your cost is going to be 33%. All right. Let's talk about RAID 5 set size of 6. So it's essentially going to do a 5 plus 1. Whoops, purple. It's going to do 3 parts. Is going to flush the disk. 1, 2, 3, 4, 5. These are these 16K page in the regions on disk. And it's going to do parity 5 plus 1. So if you create a 5 terabyte volume, it's really going to take up 6 terabytes. So your cost is 20%. And then the set size of 9 is going to do an 8 plus 1. So for every, essentially every 8 writes. It's going to use a ratio of 8 to 1. So if you think about it, if you create an 8 terabyte volume, at the end of the day, you use all 8 terabytes, it's really going to use 9 terabytes of raw capacity. So your cost is about, 12, 13%. All right. Now, so people will ask me, well, what is set size? And we're talking about set size right now for RAID 5. Well, people will ask me, well, why would I want to have different RAID 5 CPGs with different set sizes? Well, one consideration is the cost consideration, right? Because a set size of 4 is going to cost you 33% overhead. The higher the set size, like a 9, is only going to be 13%. So the lower the set size for RAID 5, the more expensive it is. So set size essentially, particularly for RAID 5, determines, the data to parity ratio. For 8, right, so it'll use another 16K for parity, another 8 on 8 different disk parity. It's hopping across, it's doing these 16K page across regions, wide striping across all of your 240 disks. All right. Now, but let's talk about availability. As I mentioned, well, okay, you're right, but let's talk about that when we get to performance. All right, so right now we're talking about, you're right. So next time I'm going to talk about availability and performance. You're right, though. All right, because there's the downside. We'll get to performance issue. Not an issue, but you're right about that. I'll get to that. But before we get to performance, let's talk about availability. As I mentioned, RAID 5 is not as highly available as RAID 1 in general, because if you lose 2 disks, it's a possibility you use the data. But the set size is also an availability consideration as well. All right. Now, the lower the set size, the more expensive it is, right? But what I want to go over here is, speaking of set size, I want to use this example here, and then I'm going to bring your configuration into the picture here. Let's say a customer has 4 cages. So they just have 4 cages here. So they have 4 cages. Let me write that up here. All right. And they have all these disks across 4 cages. Doesn't matter the number of disks. And let's say they create 2 RAID 5 CPGs. One RAID 5 CPG has a set size of 4, a 3 plus 1. And another CPG has a RAID 5 set size of 6, which is a 5 plus 5D1P. All right. So let's say they create a volume using this RAID 5 set size of 4 CPG. All right. So these little D's and P's represent the 16K page. With a set size of 4, as we write to a region, we're going to write data, 16K, data, 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 hop to another disk on another cage, and then write parity. You know, we're not showing you chunklets and regions here, but eventually it's going to write data, 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 parity. 3 plus 1. So think of this as like a stripe, 3 plus 1, 3 plus 1. Then it's going to hop to 4 more disks, data, data, data parity. Okay, so off here to the left represents my RAID 5 set size of 4. Here's a question. If I lose this cage, any of these 4 cages, my RAID 5 set size of 4 data survive a cage failure? Type yes or no in the chat room. If I lose one of these 4 cages, say I lose this, just deal with this one. Let's say I lose this cage here, the second one here. The answer is yes, because with 4 cages or more, think about this. If I had 4 cages or more with a set size of 4, the algorithm, as it lays this data out, is going to do data, data, data parity on another disk on another cage. Do data, data, data parity. We jump to 4 more disks, data, data, data parity. But if you think about it, if I lose this cage here, just deal with what I have over here to the left. If I lose this second cage here, I lose this data, but the parity for it's on another disk on another cage. If I lost this cage, I lost the parity, but the data is guaranteed to be on another cage. Right? So with my set size is equal to the number of cages I have or have more than the set size. In other words, if I had 5, 6, 7, 8 cages back here, I'd be able to lose a cage. Now, let's go over here to the right. You know, same disks over here, 4 cages, but set size of 6. This is a 5D1P as we lay the data out. Data, 2, 3, 4, 5, parity. Think of this as like a strike. 1, 2, 3, 4, 5, and then write the parity here. Then it's going to go, you know, another 5 plus 1. I'll do something like this. Data, data, 3, 4, 5, and parity here. So think about this data and parity. They're on different disks. But if I lost this cage here, the data and parity on different disks, but since the disks are in the same cage, if you think about it, for RAID 5, in my example, if I have a RAID 5 CPG that's set size of, with only 4 cages, if I had a set size of 5, 6, 7, or 8, or 9, if I lost a cage, I would not be able to survive that cage failure because parity is going to be everywhere. All right, so let's talk about this. In my example here with 4 cages, RAID 5 set size of 4, I can get what's called cage availability. With a set size of 5, 6, 7, 8, or 9 with 4 cages, I cannot get cage availability. I have to set up what's called HA mag. So let's bring this into the conversation. All right. The availability option. When you create a CPG, and I know I'm jumping around here a little bit, when you create a CPG, sorry, let me find it here. Oh, here it is. When you create a CPG in Management Cons or SSMC, there's an option called availability. The default is set the CPG up and then create the volumes with cage availability. But if you don't have the conditions met to achieve cage availability, you have to take it to what we call a lower level of availability called magazine. Now, you don't have magazines in your 7,000s, but think of this as the lower. Because like when I say the term, that when I use the term condition met, what I'm essentially talking about here is, like in this example, I only have 4 cages, and you can go in and create a CPG RAID 5 set size of 6, right? But you can only get HA cage if you have a set size of 4 or less. But if you take it up to set size 6, 7, 8, you're going to have to set it to be magazine. In fact, to show you this, I want to show you this because I'm going to go out here and create a CPG. Now remember this is one of the reasons why I showed you earlier that I only have 2 cages. When I create a CPG here, all right, choose the device type RAID, I'm going to choose RAID 5. And remember I only have 2 cages. So even with a set size of the lowest, with only 2 cages, I only have 2. Set size of 3, 4, 5, 6, I can't get cage availability. So in fact, I'm going to go ahead and try this. I'm going to click on create here. I'm going to try and create a cage availability RAID 5 set size of 4. I'm going to go ahead and do it up at the top, but up at the top, it's going to give me an error. I don't have enough cages to achieve cage availability with a set size of 3 or 4. Now, if I had 3 cages, I could do set size of 3. If I had 7 cages, the disks were populated across, I could do set size of 7 and a cage availability. So what I'm going to have to do here when I create this CPG is give it, I'll just change the RAID level to RAID 5, any of the set sizes here. I'll just keep the default. But if I set it to a lower level of availability, whenever you do this, you're basically saying, go ahead and lay the data out without cage availability. Whenever you do the lower availability, and I'm just going to click on create, and now it'll work. You're basically saying, okay, I know I have a single point of failure at the cage level if I do this, but go ahead and do it anyway. That's fine. You can do this. See, the CPG is going to be created with a lower level of availability. Okay, so one thing that when you play with the set size, let me jump back here for RAID 5, it has cost ramifications, but based on the set size and the number of cages you have, will you be able to do cage availability? We always say cage availability is best from an availability point of view, right? But it's ultimately a choice, cage availability or not, and that's the decision. So if I only had 4 cages, I might say, well, I want to do a set size of 9. In fact, let me flip back here. In my examples, remember here, let's assume they have, let me change this example. Let's say up here we only have 4 cages. These are the disks across 4 cages. Well, if we focus here, these are all 3 different RAID 5 CPGs. They have different set size. With a set size of 4 or less, you can get availability cage. But with 4 cages, if you have 5, 6, 7, 8, or 9, you have to take it to a lower level of availability, which is fine. You can do this. Just know when you create the volumes that are RAID 5, if you lose a cage, that's a single point of failure, but that's a choice. All right. Now for RAID 1, by the way, let me show you this real quick. When you create a RAID 1 CPG, there's actually a the default set size is a 2, which is data plus mirror. Write the data out there twice, 16K page and mirror it. You could actually have a CPG RAID 1 set size of 3 or set size of 4, which set size of 3 is what we call a triple. Data, mirror, mirror. So if I create a 4 terabyte volume, it's really going to take up 12 terabytes of space. A 4, set size of 4 is what we call a quad. Data, mirror, mirror, mirror. So create a 2 terabyte volume. Essentially, it's going to take up 4 times 8 terabytes. So there is a set size that's applicable to RAID 1, but I've never seen anybody use anything other than a set size of 2 for RAID 1. Okay. With a set size of 3 or 4, this is going to be expensive, right? Versus a set size of 2 for RAID 1. Not so much a performance, it's an availability thing. For RAID 1 set size of 2, like I said, you could lose half of your disk. With set size of 3, that RAID 1 set size of 3, you could survive with 1/3 of your disk. For 25%, 33% of them, you could lose 2/3 of your disk. A set size of 4, you could lose 80% of your disk. But that being said, I've never seen anybody do for RAID 1 anything other than a set size of 2. I just bring that into the conversation because when we talk about, there is a set size applicable to RAID 1. Now, most of the time when working with set size, you play with the set size, it's really RAID 5. And so it does have cost and availability consideration. Availability means, based on the set size, are you going to do HA cage or not? All right. Now, let's also talk about performance for RAID 5. Here's the downside of RAID 5 versus RAID 1. RAID 5 incurs what we call a 4 IO backend penalty. On a write. Because what happens with a RAID 5 write is eventually, if a host has to write, we have to pull the pages from disk into cache, recalc the parity, and then write them eventually back down to disk, to the regions of disks. So it's 2 IOs, data and parity from disk into cache, recalc parity, and write. So it's 2 IOs in and then data and parity out. So RAID 5 incurs what's called a 4 IO backend penalty on a write, which you don't get with RAID 1. Now, a couple of points here. Number one is sort of like Srikant, you were mentioning. This set size also will impact that 4 IO backend penalty. In other words, like a set size of 9, we're going to have to read all this in parity and then write it back out. So the higher the set size, kind of the higher the backend penalty for, impacts that. So that does impact the set size impacts the performance, but overall, RAID 5 has a 4 IO backend penalty on a write. But don't fear RAID 5 because for RAID 5, remember for any volume that's exported to a host, whether it's RAID 1 or RAID 6 or RAID 0 for that matter, whatever the RAID level is, the host, when it writes on the front end, it writes in a path to one of the controllers, hits the cache of that controller, we mirror it, acknowledge it. So from the front end, from the host, it's just write, mirror, acknowledge, write, mirror, acknowledge, whether it's RAID 1, RAID 5, RAID 0. So from the front end, doesn't matter. Yes, RAID 5 on the back end has a little bit of a performance hit versus RAID 1. If I compare everything being equal, yes. But particularly for SSDs, RAID 5 is very, very common. And I know that you are doing RAID 5. You're RAID 5ing a lot. I don't know if you're doing a lot of RAID 1, but if we're laying out the pros and cons of these, RAID 5, there's a little bit of on the back end for IO backend penalty. All right. Now there's another RAID level, RAID 1, 5, and 6. Now when you create a RAID 6 CPG, let me kind of show you this. I'm going to push this out. When you create a RAID 6 CPG, there's a set size. With RAID 6, the parity is written out there twice versus RAID 5. So it's more highly available than RAID 5. But when you create RAID 6 CPGs, there's a set size, what we call a 6.2, which is called a set size of 6, and a 6.2, which is set size of 8, a 8D2P, which is set size of 10, all the way up to a set size of 16, which is a 14D2P. So you can also create RAID 6 CPGs and then hence RAID 6 volumes. So the thing about RAID 6, in terms of cost, it's cheaper than RAID 1. But if you think about it with double parity or multiple parity versus RAID 5, where we just write it out there once, it's cheaper than RAID 1, a little more expensive than RAID 5. Now, RAID 6 from an availability point of view, it's more highly available than RAID 5. Because remember, with RAID 5, it's possible if you lose 2 disks, you could lose the RAID 5 data. But with RAID 6, you'd have to lose 3 or more disks. So RAID 6 is a little more highly available than RAID 5. Not as highly available as RAID 1, so it's somewhere in between. But it's better from an availability point of view in terms of that. Here's the thing with RAID 6, though. But from a performance point of view, it incurs a 6 IO backend penalty. Because, like, remember with the RAID 5, it's a 4 IO backend penalty. RAID 6, we got to read the data in parity. I'm sorry, data in both parities. Disk into cache, that's 3 IOs in, then recalc 2 distinct parities, write them down to disk. So versus RAID 5, which has a 5 IO back or 4 IO backend penalty, this has a 6 IO backend penalty. But it's often overlooked RAID level. Because it's kind of in between cost-wise and availability-wise, a 5 and a 6, a 5 and a 1, a little bit of a more back-end penalty. The other thing with RAID, so here's the nice thing about this whole concept of the CPG. You can create these CPGs using your 240 SSDs, different RAID levels, different set sizes for RAID 5. Here's some different set sizes with RAID 6, with different availability options and so on. And you just choose the CPG you want to use when you create the volumes, which determines the characteristics. Yeah. So there's the different RAID levels. You've got RAID 1, RAID 5, and RAID 6. Another thing with RAID 6, I want to, here's just kind of a slide that says cost, availance, performance. They're all something to think about. I talked about the set size. The set size, has, particularly for RAID 5, we think about it. It has cost, performance, cost considerations. Are you going to be able to do cage or not based on the set sizes and the number of cages you have? Can you do cage or magazine? cage magazine is a lower. There is a higher level of availability than cage. It's called port, which if you think about cage being, you're reducing a cage as a single point of failure. Like for RAID 5, if you have cage availability, it basically means the data and the parity are guaranteed to be on different cages, on different disks on different cages. So with cage availability, let's say these just represent 2 cages. With cage availability with RAID 5, you know that any data on a disk on this cage, the parity for it will be on a disk on a different cage, right? Or any data on this cage, the parity for it would be on another disk in another cage. Now for port, it means not only put data and parity on different disks on different cages, but these 2 disks on different cages, each disk has what's called a primary path and an alternate path to the disk interfacing ports on the controller nodes. So with availability port, not only will data and parity be on different disks on different cages, but these 2 disks would have different primary paths. So it's even takes cage 1 level higher. And the other thing too I want to point out is this chart. Over here, they're basically telling you how many cages do you need to get cage availability. Well, for RAID 1, think about this. When you create RAID 1 CPGs and RAID 1 volumes, you'll get HA cage as long as you have 2 disks populated across 2 cages or more, right? You're going to get HA cage. Now for RAID 5, the set size has to equal the number of cages. Like for example, RAID 5, if I do a set size of 4, a 3 plus 1, I'll get cage, HA cage if I have disks spanning 4 cages or more. For RAID 5 set size of 8, I can do set size of 8 with HA cage if I have disk populated across 8 cages or more. But look at RAID 6. For RAID 6, you only need half the number of cages. In other words, RAID 6, like set size of 10, 8 plus 2, I don't need 10 cages, I only need 5. For RAID 6, set size of 8, 6 plus 2, I don't need 8 cages, I only need half the number of cages. So for RAID 5, it's 1 to 1, right? So if I have RAID 5 set size of 4, I need 4 cages. So RAID 6 is more highly available than RAID 5 in that sense because maybe your odds of achieving cage are better. Okay. All right. This I went over. There are a couple of other things I want to go over here as well. All right. But we've been at it for about an hour. We got a few more things to talk about with CPGs. But let's take a quick 10-minute break, and when we come back, we'll pick up where we left off. Beating my phone. See you in 10 minutes.